Hi, welcome to Math with Beth. And we're going to look at models of limited growth. So if you haven't already looked at the video of uninhibited growth, you might want to do that first, because that's where the growth just keeps getting larger and larger and there's no limit. But for these, there will be a limit. So there's two different equations for limited growth. So this is the first one we're looking at, and it's called the logistic equation. And so there's always going to be some number, they're calling it L right now, but it's going to be a number that is the limit. So there's going to be some kind of limit to how large this thing can get. So in this type of equation, it has a starting place. It starts getting bigger and then has a kind of a biggest growth spurt right here, you could say. And then as you see, it gets smaller and smaller until it gets to that limit. So the growth rate is increasing until here, and then it starts actually decreasing. So here's the equation, L over 1 plus C. C is just going to be some number times E, which we know is the value 2.71, blah, 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 to the negative R times T. R is always the rate. Here they're telling you what the equation will look like, but depending on what's happening, we can just find the derivative equation ourselves. You don't have to memorize this. So in this type of an example, there is going to be some value here in the middle that's called the point of diminishing returns, and it happens to be half of the limit. So whatever your limit happens to be, if you divide that by 2, you would see the value of this point. And L is the limiting value, and it has a horizontal asymptote at that point. So the graph never quite hits it. It just gets closer and closer and closer. So let's do an example and see how we would use this. If they told us that Netflix revenue are in billions of dollars, T after the years 2016, so that means consider this like year 0. And so whatever year we're going to talk about, we need to figure out how many years has it been since 2016. And this is our equation. Okay, find the estimated revenue in 2025. So first, we need to think about what that really means, because it's not that our T is 2025. It's 2025 minus 2016, because that's how many years it has been. So first, when they give you a year, figure out what the T actually is by subtracting the starting year. So in this case, T is 9. So now I can just use my equation to find out what the revenue is at year 9 by doing all of this on the right side. So I'm plugging in 9 for the T, and I'm going to see what all that gives me. So it looks like it is about 33.39 or 33.4. And remember, we're talking about billions of dollars. So that is what the revenue was in 2025. Now it's asking me for the estimated growth in revenue. So again, that means derivative in 2022. So this one is trickier as far as finding the derivative, because you have to think about the fact that it's really like a quotient rule type situation. So the derivative of this equation up here, so I'm going to go back to R of t, not when I plugged in numbers. The derivative of that would be the bottom of the fraction times the derivative of the top, which luckily is 0, so that's going to make things nicer, minus the top times the derivative of the bottom, which is just going to be 0 here, plus, and remember our derivative of anything with an e is that it all stays the same, but then you multiply by the derivative of the exponent. So that would be an extra little negative 0.46 there. And then that's all over the bottom squared. So this is just using the quotient rule. So that's kind of a mess, but at least now we know we can plug in 6, because they want us to know what's happening in 2022. So 2022 really means T equals 6 because it's been 6 years since 2016. So this gets a little nicer because all of this is being multiplied times 0. So you can just wipe all of that out. And over here, you have 3 things that you could really multiply together. So let me just make this a little nicer before we plug in our 6. And I don't want to round, so I'm just going to write as many numbers as I see in my calculator. So this is what I got when I did negative 34.99 times 3.012 times negative 0.46. That's why it became positive. And then the E stuff stayed the same. And on the bottom, I'm just going to leave that as 1 plus all of this squared. So now if you carefully plug in 6 to all of that, you should get about 2.16, which really means that the rate is increasing to $2.16 billion per year at year 6. Okay, and then finally, find the revenue at the point of diminishing returns. That's a lot easier because remember, that is really just the limit divided by 2. And so our limit, even though they never told us, we can tell just by looking at the equation because it must be that number on top. So we just need to do 34.99 divided by 2. And so that is our point of diminishing returns, which means after the revenue is that much, the rate is going to start decreasing, right? Because that we just found the revenue at that point. So after that, the rate is going to decrease. So that is using the logistic equation. So now the other limited growth function is this one. So notice it also has a limit. That's why these are both called limited growth equations. But the graph is a little different. Because remember last time we started, we went up and then we got closer to the line, where here it's just constantly going up the whole time. But it's definitely going up faster in the beginning and then starts slowing down as it gets closer to the limit. So this is the equation, which is a little nicer. At least we don't have a big fraction. So let's do an example of using this one. The price of headphones of a new model sells for $45 per set, and then 5 weeks later is selling for $52. Market analysts expect they will sell for a high of $70. So that is your hint that there is a limit, right? They're giving you a high number. So that's going to be the L. So use the limited growth model, which is this equation, to find P of T, the price of the headphones after T weeks. So right now we're just trying to find the equation. So let's see what we know and what we can maybe figure out. L we know is 70. C we don't know. E is just E. K we don't know. And T we don't know overall, but we do have 2 examples, right? So I'm going to use those examples to figure stuff out. So basically, if they say it sells for $45 per set at first, and then 5 weeks later, 52, this is what I'm really hearing. That when the time is 0, it's $45, and then 5 weeks later, it's $52. So let's use that information. So if I use the first point and plug 45 in here, because that's the answer, when T is 0, that's going to help me solve this because E to the 0 is really just 1. So all of that really just turns into C. And so the first thing I can do is figure out my C by subtracting that 70. So now I have C, but I still don't have the K. So now I'm going to use the other piece of information and plug 52 in. The 70 will still be the L. We now know the C is negative 25. E to the negative K, and T in this case is 5. So I went back again, plugged in the C I just found out, and now I'm using the other piece of information to plug 5 in here and 52 in here. So the first thing I can do is subtract the 70 again. So that will give me negative 18. And so now we're here. Now I'm going to divide by that negative 25. And I'm here. At this point, if I want to get rid of the e, which I do, I would need to do the natural log on both sides. And my pens aren't working. I just want to show you that I'm doing that on both sides so that I could wipe out the e. So whatever the natural log of 0.72 is, and this is basically the same as that, right? So my last step to find the k will be to divide by a negative 5. So ln 0.72, and then just make sure to end your parenthesis divided by negative 5. So I'm just going to round that, and so that is my k, 0.06. Let me see how many places I rounded it to. 57. Okay, so what was the whole point of this was finding the equation, right? So remember I had to do all of this work to find the c, and then I started over and did all of this work to find my k. So now I have my equation. 70 minus 25e to the negative 0.0657 times t. So now it wants me to find p prime of 15, which means find the derivative when t is 15, and then interpret its meaning. What does it actually mean in this problem? So when asked to do anything with the derivative, we first need to find our derivative. So luckily, the derivative of 70 would be 0, so that part's easy. The derivative of anything with an e is going to be the same thing you see, but then times the derivative of that exponent, which in this case is just the decimal. Again, I can make it a little nicer because I'm always allowed to multiply these things. So I can do the negative 25 times negative 0.0657. So this is my equation for my derivative. So now, what did they want me to find? The derivative when t equals 15. So I'm going to plug in 15, and then we'll talk about what it actually means. So I got a decimal, but let me think about what that actually means. We are talking about the price of these headphones, right? And derivatives always tell you a rate. So basically, this is an amount of money. So it's basically 61 cents, right? So this is the rate, the price is increasing per week at week 15. So when you get to week 15, this is the rate that the headphones are increasing in their price. Finally, when will the headphones be $65? So this has nothing to do with rate, so I don't need a derivative. So I just need to go back to my original equation and find out when it would equal 65. So definitely reviewing some of the rules of exponential graphs and how to solve equations that have e's in them would definitely be helpful, because the new equations aren't that bad, but it's doing all of this math dealing with e that might be troublesome if you haven't done it in a while. So how would I solve this? I'm going to move the 70 first by subtracting. So I subtracted 70. Then I'm going to divide by 25, negative 25. I want to get the e all by itself. And then I can always eliminate the e by doing the ln of both sides again. So hopefully you do a couple of these and you'll get the hang of it. So once I get rid of the e, I'm here. I'm just leaving this as ln 0.2 right now because I'm going to put it all in the calculator at the end so I don't have to round early. So my last step is to divide, and we will have our t. So I need to do ln 0.2. I need to make sure to end that parenthesis so then I can divide by the decimal. So we get about 24.5. So that is how many weeks it would take for the headphones to cost $65. So again, I went to the original equation, just set it equal to 65, and then I solved by moving the 70, dividing by the negative 25, then taking the ln of both sides to get rid of the e, and dividing. So it's this many weeks. So these really aren't as bad as they look, but they do take practice so that you're not super intimidated by the equations and all of the letters involved. So definitely try some. Let me know if you have any questions or if you need to see more examples. I'll be happy to do it. Thanks.